Earlier I mentioned that different fuels provide different amounts of energy. But how do we know this? This is a special area of chemistry called thermochemistry. In thermochemistry, chemists examine the energy that different chemicals absorb or emit. The chemists measure the temperature of different reactions. Temperature is the measure of the average kinetic energy of the atoms or molecules present in a substance. This is all on page 172 if you didn't get that definition. The change of this temperature is the heat. Heat is the kinetic energy that flows from hotter objects to colder ones. So if you heat a pot of boiling water, you are transferring the kinetic energy of the stove to that of the water inside the pot. And this then changes the average kinetic energy of the water, hence changing the temperature. The picture on this slide is a calorimeter. Notice the word bomb here. That is referring to what's inside the calorimeter. It is a device that experimentally measures the quantity of heat energy released in a combustion reaction. The substance that is combusting is set on fire, is placed on the container in the middle of the machine. There is an electrical wire that goes through the compound to light it on fire. This whole center area here is called the bomb. This is where the reaction is taking place. As the compound is lit on fire, the bomb gets hot. Surrounding the bomb, inside the insulated container, is the water. This whole area here is water. The water is heated from the reaction taking place in the bomb. The stirrer makes sure that the water is heated evenly and that there is not a warm spot next to the bomb and cooler further away. The thermometer measures the amount the temperature rises during the combustion. This is measuring the heat of combustion, the quantity of heat energy given off when a specified amount of a substance burns in oxygen. A similar way to this could be how the scientists determine how much energy is given off from the different fuels. Hydrocarbons like methane burn in the presence of oxygen to produce carbon dioxide and water. Energy is released in this process called combustion. When energy is released during the course of a chemical reaction, it is said to be exothermic reaction. If we break down the words exo and therm, exo reminds you of exit, therm reminds you of heat, or thermometer, or temperature, something along those lines. So the heat is exiting. So in an exothermic reaction, the heat is leaving the system. To examine it more closely, in an exothermic reaction, the energy required to keep the atoms of the products together are less than the energy required to keep the reactants together. The difference in this energy is seen in the extra energy and is given off to the reaction's surroundings, sometimes in the form of heat. So this difference here is the heat that you feel when you set things on fire. As discussed earlier, not all fuels give off the same amount of energy. This picture shows how the energy changes from one source to another. Notice methane is the largest difference, and so it would give off the most energy. So in comparison to the rest of these, methane is the best energy source. Not all reactions give off energy. Some reactions actually absorb energy. These are called endothermic reactions. Just like how we broke down exothermic, we can break down endo by going enter. So the heat enters the system. Endothermic reactions will have products higher in energy than the reactants. This means that the reaction needs extra energy to make it react. The reaction gets this energy from its surroundings. To summarize exo and endothermic, endothermic absorbs energy while exothermic gives off energy. The energy changes are due to the arrangement of the atoms in the reactants and products. It is the breaking and forming of bonds that dictates if a reaction will be endothermic or exothermic. Bond energy is the amount of energy it takes to be absorbed, that must be absorbed to break a chemical bond. Breaking bonds always requires energy. This graph shows how chemical reactions of hydrogen and oxygen react together to give off energy. Notice that oxygen breaks and gives off, bonds break and give off energy, and there are two hydrogen bonds that break and give off energy. When they form together, when the water is formed, there are two bonds in water, two OH bonds. There's one here and one here. There's a 2 in front of the water, which means we had to multiply that by 2 again, which is why they get 4 here. Since H2 and O2 bonds are breaking, they are giving off energy, and since OH bonds are forming, they are absorbing energy. By taking the difference between the left and the right sides of the equation, you can determine the difference in energy. So this reaction gives off 498 kilojoules. Let's turn our attention to gasoline, since that's something that we're most familiar with. Gasoline is a petroleum product in very high demand. As a result, some of the hydrocarbons that are in less demand are treated to create more gasoline. To make gasoline, scientists have sometimes taken larger hydrocarbons complexes and reduces them down into smaller compounds. For instance, they will take tar that is not in really high demand and crack it, in other words, break it in two to make smaller hydrocarbons that can be used for gasoline. If they have smaller hydrocarbons, they can combine them, called reforming, to make larger and capable of being used, larger compounds that are capable of being used in gasoline. Something else you may have seen in the gasoline is what's called an octane rating. Those are because of isomers. Isomers are when two compounds have the exact same chemical formula, but the atoms are arranged differently. In this picture, there are two compounds of octane because it has eight carbons. If you count all the carbons here and all the carbons here, you'll notice that they both have 8 carbons. You'll also notice that they both have 18 hydrogens. Scientists have learned that the knocking that occurs in engines are a result of these isomers. Both these structures are found in gasoline. The compound on the right tends to burn better in the engine. The compound on the left tends to ignite when it's not supposed to. And this reaction of it igniting sooner is what's causing the knocking sound. So when you see different octane ratings, you may have heard or seen octane ratings on while you were pumping gas. This octane rating is intended to distinguish what percentage of gasoline has the more compressed structure, the one that was on the right-hand side on the previous screen. So 87 octane has 87% of the good structure, where 91 octane has 91% of the good structure. To improve the octane rating, chemists were using tetraethyl lead to reformate the gasoline and increase the good octane and prevent knocking. However, there was a large and understandable desire to get rid of this additive because of the lead. The chemicals you see on the screen now are the new additives that chemists are using to increase octane level of gasoline. In addition to not containing lead, researchers have noticed that the gasoline is burning cleaner with less pollutants. That's why you always see unleaded gasoline. With the concern of running out of gasoline in the future, scientists and engineers have been looking for alternative, sustainable, and renewable fuel sources. Biofuels seem to be a decent alternative for now. These are fuels derived from plant matter, such as trees, grasses, agricultural crops, and other biological materials. Compared to fossil fuels, burning biofuels should release less carbon dioxide because the plants from which the biofuels are grown can also absorb the carbon dioxide from the atmosphere through photosynthesis. Biodiesel and ethanol are two examples of biofuels. Biodiesel fuel use is on the rise. Made from natural, renewable sources, vegetable oils, and animal fats, it can be used as pure fuel or blended with petroleum. Ethanol is renewable, but more expensive than gasoline. Some believe it takes more energy to produce a gallon of ethanol than it will to obtain it from burning it. The E85 gas that you see in gas stations contain 10% ethanol in its mixture. Scientists believe that the ethanol blend burns better in the engine and reduces the knocking, but it does seem to burn a bit faster, decreasing how far you can go on a tank of gas. There are some issues with ethanol as well. Economically, it is still more expensive to use ethanol mixture than to use straight gasoline. Part of the reason we are seeing it used more often is because the government is supporting it so much financially. Environmentally, it takes time and efforts to produce the ethanol. This is not only true of human work, but also for the earth. The crops need to be planted, cultivated, and harvested. In this process, we use pesticides, herbicides, fertilizers, tractors that use gas, and etc. Socially, it helps the farmers and the Midwest because they are seeing a profit of the ethanol. Also, the distilleries created, the jobs are too. However, the increase in production of corn is decreasing the production of other crops, which are then in turn raising the price of the other products. Biodiesel is another alternative energy source. It is produced from vegetable oil and animal fat. Biodiesel is more energy efficient than fossil fuels because it produces more energy when it is burned. One of the byproducts of the biodiesel is glycerol. Glycerol is then used in cosmetic products, pharmaceuticals, paints, and many other items that you use. This brings us back to the cradle-to-cradle versus cradle-to-grave analysis. Because the byproduct is used as a starting material, we are prolonging the life and usability of the substance. Another energy source that is currently being used and further developed is the burning of garbage to produce electricity. This solves two problems at once. The fossil fuels are being used less, and we have found the renewable energy and the garbage is being reduced because we are burning it instead of putting it in the landfills. It does not completely remove all the waste, but it's only 10% of what it was before. Cities like Minneapolis are already using the process to produce energy. This graph shows the energy consumption of the world broken down to categories of their economies. For instance, America is a mature economy, so it is on the blue line. India and China are considered emerging economies, so they are represented by the green line. And Eastern Europe is considered transitional economy, they are represented in the red line. What you may notice is that with all three projections are going up. This means that as our population grows, our need for energy will also grow. Also, as I said at the beginning of the semester, it is up to us to make good decisions and get involved. Hopefully taking this course has helping you realize this a little bit more.